Hello everyone, welcome to the stream. Okay. Just get all set up. All right, so yeah, so last week we did a lot of work on Linux actually for the past few weeks, and I'm pretty happy where that went. Oh, hey Backface, how's it going? Long time no see. So yeah, we did a bunch of work on Linux, and it was looking pretty good. So I'm pretty much done on that front. We had a couple of things that were kind of left to do, but I don't think they're super important. I think that the main stuff is there. There's still the Mac port that I have to do at some point, but I need to get an actual a Mac in order to do it. So since I don't have one yet, I'm gonna wait till later. And I think I'm just gonna get started on the last major feature that I really need to do, which is audio. I started reading about it. I'm actually using Malban's documentation that he wrote, which is actually quite good. Let me see if I can link to it. Yeah, I think it's like totally the wrong link, but basically I can do this. Oh yeah, you can lend me one? I mean, it doesn't have to be super awesome or anything there. Like, you know, if I'm able to put, yeah, I don't know. I don't know how old it is. I don't know how powerful it needs to be. I mean, my computer is about 5 years old, and it runs decently well on it. But yeah, Backface, if you wanna, we could talk about it off stream and try to set something up. Set something up if that works. Okay, so I think it was in Docs. Like, is it like really old? Like, we're talking like 10 years old, or like, what are we saying? Because I mean, obviously, if it's too old, I might not be able to even like get it running. At least maybe get it compiling. Maybe running it very slowly. I don't know, because it does use, you know, GLSL. I think it's just 3, so it's not a major thing. But still, if you tell me that that's supported, I know so little about Macs, you know, so I don't really know. What am I using again here? 3.3, OpenGL 3.3. And I don't remember if yeah, 330 for the shaders. Which I guess probably supported by really old Macs. Does it need to have like a recent version of OS X for it to be able to, like, is that like a requirement, or can you run old OS X and put the latest toolchains on it? I'm such a Mac noob. By the way, speaking of Macs and porting, today I didn't read too deeply into it there, but I saw like that Apple has announced that they're gonna no longer support OpenGL for OS X, which seems crazy to me. I think they're gonna just drop it altogether and continue to develop, I think it's Metal. Which basically means we won't have an easy cross-platform solution like OpenGL for the 3 major platforms. which specifically for my emulator would suck. Now, I'm sure it's going to take a while before OpenGL is fully deprecated and not working, but still, at one point, we can imagine it being more difficult to port stuff. Yeah, the Xcode version is kind of linked. Yeah, so I'm using, I mean, that's one thing, is I do kind of need an updated compiler, and because I'm using C++ 17 features. So even like on Windows, I have to have a pretty recent version of Visual Studio 2017 installed. So yeah, I think so, Backface. I think that means that they'll be pushing Metal across both Mac and iOS. I think they're just tired of supporting OpenGL, and I mean, I think they've always had kind of weak support for OpenGL anyway. But anyway, to me it just sounds like kind of bad news for those of us looking to do cross-platform without, like, you know, busting our heads. But who knows? Maybe someone will write some kind of OpenGL wrapper around Metal that will just give us what we, you know, the core of OpenGL that we use. I can see an open source project doing that kind of thing, you know. Oh, thanks for looking into that. Really appreciate it. All right, so I think this is built. Hey, so Backface, have you seen the emulator in a little while? So this is what it's looking like. If I maximize it, you can see I have like a menu here. I don't know if you saw it with the menu, but basically I'm using ImGUI to do all this rendering up here, and like the rendering of this debug window here, and what else, of this window here when I do help. And you can click this and it opens up in my trusty browser here. You haven't seen this, eh? And close that. What else can I show you that's kind of cute? Obviously I have the break into debugger thing. I think you saw this, the debugger, where you can step, you can show like the last 10 instructions or the last 100 instructions here, and there's a whole bunch of stuff you can do, and you can continue. Thanks. Yeah, it's pretty fun. There's some pretty nice games in here. So what can I show you? One that I really like is this Moonlander one. Let's fast forward a little bit. This is actually a homebrew ROM, which is why it's so cool. I'm trying to remember how to play this. Okay, that's it. Boom. Obviously I have to slow down and not use too much fuel. Yeah, this looks like a classic arcade game, actually. It says okay, so there we go. Good landing. This is really cool. Next Moon, Smith Engineering, which is the name of the company that made the Vectrex, by the way. So I guess we want to land where it says ×2, ideally, right? I'm going to try to use the least amount of fuel as possible. Damn. Not easy. Keeps pulling me back. Oh, it's like, okay, there's like a gravity that's pulling me.
Hi, this is Tim at the bakery.
Damn it.
Cookies that you ordered should be
Go.
Make sure that you read carefully.
Lunar wind? Oh, it's the lunar wind. Okay. Did it say something that it was a lunar wind? Or you're just saying that's what it is? It said okay. You know what, maybe instead of working, I'll just play this game all night. Okay. Alright. So I'm going to get started kind of slowly, because actually there's like a lot of reading that I have to do. I was looking at, where was it again? Like PSG... sound, some notes on how the PSG works and how it is programmed, how the BIOS routine handles ADSR envelopes. Let's see here. This technical line 6522 and the PSG. So where's that link that I found? It was PSG1.htm. I thought it was linked from here. No? I guess not. PSG1. Okay, well, let's just open PSG1 then. Okay, yeah, so this was this page that basically describes the AY38912 programmable sound generator. So this is the PSG. So this is basically the chip that I need to emulate. So yeah, I started reading this and I started taking some notes. So it's kind of interesting. You know, the sound for the Vectrex is fairly simple. What do I write here? So it's got 3 tone generators and 1 noise generator. And then these 4 sound generators are accessible from 3 voices, which are channels. What does that mean again? So 3 tone generators map directly to 3 voices, while the noise generator may be used by any of the 3 voices. Okay, so tone generator 1, 2, 3 always played through voice 1, 2, 3 respectively. Noise generator can be played through voice 1, 2, and or 3. If more than one voice uses noise generator, what is it all said? They all play at the same time, I think this was. They all play at the same time since there's only one noise generator. Okay. I guess it's just a detail, but basically if a game was to assign a noise generator to, say, 2 of the voices, both would just play the same thing. Which doesn't, I don't think it changes the volume or anything, it just means that you only hear the noise. So I guess like if you're not using noise, you can hear 3 different tone generators. If you use the noise on one channel, then you'll hear 2 tone generators and that one noise on that one channel. So that's how you can program it. And then it talks about there's 15 registers. So we're going to want to memory map these and like basically intercept reads and writes to these. So yeah, here's an example of how it's done. Basically you load 0 into A. You load the register that you want into B. So register will be FF, which I don't remember what that maps to. What does it say here? It's not FF. Anyway, it's one of the 15 registers. This will be the 15th or 16th, I should say. And then you jump to this byte to sound chip. So the idea is to send bytes. The way it's done from the point of view of the BIOS and from what you do from the CPU is you effectively just want to send these bytes to the sound chip, and there's this BIOS routine that takes care of doing that correctly. Let's see here. Okay, and then this is how you program those tone generators. It's kind of interesting. It's basically 12 bits. Each tone generator gets 12 bits. So tone frequency is a 12. Why did I write 12 byte value? 12 bit value, right? Tone frequency is a 12 bit value from 000 to FFF. So there are 4096 possible frequencies, or tones, I guess. Noise frequency is a 5 bit value from 0 to 1F, so there are 32 values. And then you have the volume. And all of that is basically programmed by here, you set the low 8 bits for the tone generator 1, and then the upper 4 bits in register 1 here. So 2 and 3 is used for generator 2, register 4 and 5 for 3. Register 6, 5 of those bits is for the noise generator. In register 7, you have tone, noise, on-off switches for voices 1, 2, and 3. I'm sure that we'll see how those are mapped. Here, register 7. So these are how the bits for register 7 are used to basically turn on and off the channels, the voices. And then volume is okay, so you control the volume for each of the voices here. And I think, yeah. And that's it. That's all I had so far. I was reading this maybe a couple weeks ago, and I basically gleaned that from reading this documentation. I don't know if it was this one though, to be fair. I don't think it was this one. I mean, there is information in here about it. But like, this is like the more low level information for the chip itself. This what do you call it, the spec sheet, which I'll read it because there'll probably be some interesting stuff in there, maybe timing related stuff. But I think the document that I was reading with the main stuff was, yeah, this one here, sound.txt. I'm just gonna fix these links here. Tutorial, Malben, I don't need the %20. That. Okay. Hey, so Backface, I don't know if you saw, but I actually wrote to you on GChat today, and I think a couple weeks ago. If you get a chance to check that out. Okay, yeah, so it was this. So by Christopher L. Tumber, who wrote quite a bit of the documentation in the early days. This is from like June 1998, and what? He kind of gives like his understanding. There's a table that you saw. But see, there's some stuff he doesn't know for sure, like ADSR envelope type manipulation and stuff. Oh yeah, no problem, backface. Yeah, I mean, I think it's a good start, you know, reading through this, getting a feel for what we have to do. Like, we can start implementing. I kind of want to approach this from two sides. You've got the side of implementing the actual register, handling, and, you know, basically getting this information for the different channels, and we can start modeling that. And that's kind of like, I'd say, the front end for the audio part. And then there's the back end part, which we can also start doing, which is basically hooking up audio to play through the sound card. And for that, you know, I did the hard work when I worked on my NES emulator of getting that kind of stuff set up. So my goal is to, or my plan is really to extract code from my NES emulator and adapt it for Vectrexy. And there are things I already know that I want to do differently. There's some stuff that was quite different in my NES emulator. For one, it wasn't really, well, it was sort of time-based, but it was sort of frame-based as well. So I need to like make sure that we are more time-based like we are for Vectrexy, where we have variable frame times. And I might have to play with buffering audio, something I didn't really have to do for the NES for the same reasons. So we'll have to look at that. I also want to change the way I did things. On my NES emulator, I had a less clean separation between what I'm calling the engine, right? Like in Vectrexy here, I have this SDL engine. And the whole idea is that the fact that it's SDL and OpenGL is not known to the rest of the emulator core. That's the kind of clean separation that I wanted this time around. In my NES emulator, it's not so clean. Like spread out throughout the NES, like the emulator core for my NES emulator are calls to things that are SDL. In that case, I had kind of made the conscious choice that SDL would be the only kind of platform I would support anyway, but I didn't want to limit myself in this emulator. And also, I just think it kind of keeps a cleaner, it makes a cleaner code base, like something easier to understand. So I'm gonna have to do a little bit of adapting the code there. So I think I'm gonna start with that. Even though we won't be able to actually hear much, I think just having something in place, then as we start to get the channels up, you know, we can maybe just like implement one channel and just see if we actually get audio working for it, you know, and I think that'll be more rewarding. Plus, I haven't actually read a lot of this stuff here, so, you know, rather than spending time reading on stream, I'm going to try to do as much as I can of reading off stream, and then there'll be some reading on stream as well. It's unavoidable. All right, so let's see here. I'm going to open up another instance of Visual Studio. Okay, so let's see. I'm just going to refresh my memory a little bit. I know that it's this here audio driver. Oh, I see that my CMake solution does not include header files for some reason. Oh yeah, look at that. I'll just do this. Probably work. There we go. Okay, so there's audio driver. So this is clean. It doesn't have much, doesn't expose much dependencies. But here, you can see I have SDL stuff here. And I mean, that's probably fine. I think I'm going to keep my audio driver as is for the most part. And this will be called directly from the SDL engine. So this won't be exposed. But I think in my code here, I do maybe expose it. Let me see. Yeah, this add sample call probably comes from the APU. So the APU here is aware of the audio driver. It's not terrible or anything. But I'm not sure if that's how I'm going to do it. I think what I'm going to do is something similar to what I do for rendering lines. That is, I'm going to pass this like render. I pass a render context. So I'm going to pass a audio context with like a list of samples. And every frame we're just going to add samples to it. And then I'm going to basically pass that to the audio driver. So that'll just keep that separation clean, and it'll be easier to port to platforms that don't have SDL, for instance. Just try to remember a little bit of how this code works. It's fairly straightforward. Got some pimple going on here. Add sample. I might actually get rid of the pimple since it's going to be directly called from SDL engine. I don't really need to hide this. See, at least I was trying to hide the fact that it was SDL in the CPP file and keeping it agnostic in the header file. So that's not too terrible actually. Yes, I'm going to need my circular buffer. I have the stream classes already. Oh yes, output raw audio file stream. Yeah, this was kind of cool for development when I didn't have it actually outputting to the speakers. I was able to. This is just really useful. Like it basically writes out to a raw file the data that is being passed in. So I just write values out there. Every time I add a sample, I also write it to a file, and then later on we can listen to this file. And that was useful when I was trying to debug for my NES emulator. I was able to look at what the curves look like and the frequencies look like directly in SoundForge or some audio editing tool. Okay, there's an audio callback. I think this is part of the whole SDL thing. Let's see, yeah. SDL and its subsystem. So we set the desired frequency. I think I have it fixed at 44.1. Apparently supported by all drivers. So here I had the sample format as a sine 16. Right, yeah. Backface color is saying with a little wave header, it becomes a wave file. That's true. I didn't need it at the time because I just could open raw files in SoundForge and it did the trick. But you're right. If I wanted it to be a proper wave file and have it open easily in other tools, then yeah, that would make sense. So I did one channel because it was mono, and why not? I think I'm going to do the same thing for the Vectrex because it's mono as well. Have your samples per callback. What's this about again? SDL audio spec. See, I'm passing a null. Interesting. Desired. I don't remember what this was about. It outputs the obtained, so I guess the current one or something. Oh no, okay, desired is what you wish for, and then what you get out is what it actually was able to set. And it looks like I was ignoring that and just saying my audio spec is my desired, because I guess I didn't care. I don't quite understand if that makes any sense. Then I'd ask for sample rate and I was getting not the actual one, but the one I desired, I suppose. I don't think it really made much of a difference. Why was I even getting the sample rate? Ah, yes. Yeah, this was some trickiness I had to deal with. I had to compute how many CPU cycles per sample would elapse. And then I would count how many elapsed CPU cycles we had so far. And once we crossed our threshold, I would subtract this. And then I would say, okay, now we have collected enough data or enough time has elapsed that we can now add a sample. Yeah, this is really hacky. I'm gonna have to think of something better, I think. Sample sum. Yeah, it's coming back to me now. It's been a few years since I wrote this code. So I have a master volume, and then for the NES I had all of these different channels. Pulse, triangle, noise. I didn't do the DMC thing. Then I computed a specific sample here. So sample channels and mix, and I would get that, and I would sum up the samples and count the number of samples. And then when we were ready to fill the sample buffer at the current output sample rate, so as soon as we hit our sample rate, then I would go and divide the sample sum by the number of samples to get an average sample. That's it. Oh yes. I'm probably gonna have to do something very similar. Kind of buffer up. That's basically what I'm doing, is I'm buffering samples. Okay. Alright. I wonder why I put this code here. Why didn't I like push some of this logic directly into the audio driver? It would seem a lot simpler. The audio driver is totally aware of its own sample rate and everything. We could just pass it the delta time. I think that's it. It's because, you see here, I have no concept of delta time. I just have a concept of CPU cycles. Whereas for the Vectrex emulator, we do have delta times. So we can actually do this more easily by just accumulating time, or even just averaging our samples based on time. What was I doing with this frame counter? Oh yeah. This piece of code, the APU implementation for the NES, this took me probably as long to write as the whole rest of the emulator. I remember it was quite challenging to get this right. It's like full of magic numbers too. But my goal at the time was not to cheat. As much, like pretty much what I'm trying to do with the Vectrex. Basically, I didn't want to look at any other emulators and just figure it out by reading documents and stuff. And for audio, that turned out to be pretty challenging because it's so specific. There's so much timing stuff to get right. And a lot of time it came down like to, you know, making sure that I had this extra if here, or when I would subtract, or, you know, like you can see that the logic looks simple, but these rules of when things happen, this happens like every clock or every time we tick it. The order of operations is very important for the audio to sound right on the NES. Stuff like, you know, it's not greater than or equals, but it's while it's greater than 0, we do this, and anyways, all these little things. I just remember having to mess around with this logic until it started to sound right. Alright, well I guess we could start moving code and seeing how that goes. Do I actually have a circular buffer already? I think I do. Yeah, I do. Yes, I remember moving this here. And we're using it for the circular buffer of instruction trace info. I remember having to make some changes. I don't know if that's going to cause any issues. I think it should be okay. We'll find out. Yeah, Backface, that was definitely a lot of work. But it was fun, you know. I was staring at waveforms in SoundForge and, you know, isolating channels and trying to understand how it's supposed to work. And it was kind of fun too, because, you know, I love NES music, and I was using Mario 3 as my main ROM to test the audio, so it was really fun to kind of start to hear the audio for each of the channels start to come through. Yeah, that was really exciting. Definitely, if you're going to write an emulator, write it for like your favorite system that you spent a lot of time playing, because you really need to like kind of know it intimately to know if you're on the right track. Yeah, I'm thinking I might even rename this to SDL audio driver, because I'm gonna like make it very SDL specific. All right, let's copy this and the header file as well. Did I not copy the header file? I did not. What? Oh, I renamed it. Oh, that's smart. Audio driver .h. Yeah. Let's try that again. Why is my F5 working? Oh, there we go. Okay, so I'll just call this SDL audio driver, like that. gonna get rid of all this pimple stuff here. And I'm gonna move like a circular buffer. Stream. Okay, I'm just gonna do this for now, and we'll move stuff slowly. Oh, you know what? Maybe I will keep the same thing. Because actually I'm thinking for compilation time this will just be faster. And anyways, I have some pimples in this code base already. It won't actually hurt. Yeah, float 32. Well, I don't even know why I did that. This is int 16t. This will be uint 16t. This will just be float. Do I have any other ones? Float. Ah yes, fail is not the same anymore. I think I have fail message. Yeah, this is what I was worried about. I don't remember what it is. I changed some stuff in circular buffer. Let me see. So I added a pushback const tref value. What did that replace? I had a push const t value here. Pushback const tref value. Oh yeah, I did a better job. I rewrote it in terms of this pushback. So what's the problem now? Cannot convert argument 1 from const sample format start type to a non-const type. Is that the problem? Oh, okay. It's just this pushback here doesn't take it by const. Should it? Does it make a difference? What does it do with this? I don't remember. Maybe it can take it by const. Let's find out. Seems to build. See if the debugger builds as well, because I know it uses it. Okay, alright, so that's it. Looks like that. That was all we needed to do. Yeah, definitely going to not use a raw pointer here. How I use this thing. Oh yes, and I need to put some size here. Ah, 512. Now we can. Do I need to do some kind of init? I think I do. Okay, I don't actually. This means I can get rid of the constructor and destructor. Just curious. Looks like 32 bytes is big enough. What about 16? I think I did need to put the constructor destructor, but put the default ones in the CPP file, if I recall. Yes, I did. Yeah, okay. Okay, so now it's not big enough. Yeah, so I think here the idea was you just add a single sample have this M samples circular buffer to which I keep pushing back. And then I have this callback that will pop back. Okay, yeah, and the callback feeds in how large the byte stream length is. Oh yeah, and I have this. If I'm underfilling my buffer, if I'm not filling it fast enough, then I just write zeros. And then that sounds like basically the sound cutting out. It also hides the problem when we start. I think because when we start the emulator, we're not really feeding any samples, and so during that time, we just want it to be quiet. So I'm going to call it SDL audio driver here. Oh, and I need to change this here. Oh yeah, I need to keep them separate. I want to make it an internal. Why do I even make it an internal class? I don't need to, right? Yeah, there's no need to do this. I don't remember why this had to be friend. It does not. Yeah, and the last thing I'm going to do is I'm going to, just like for the CPU, I'm going to put this inside my anonymous namespace here. Why is this getting tabbed out though? Oh no, I'm not doing it for the CPU. Oh, what do you know? Alright. Well, if I don't do it for the CPU, it doesn't really make a huge difference. Technically, it should be anonymous. It should be a static class, effectively. But whatever. I kind of like it as flush left as possible. Okay, so we've got this. I'm going to need to initialize the shutdown step, the format I went for. Init, reset. Init, reset. It looks like I don't even have a shutdown on most things. have initialize here. Okay, it's fine. We'll keep it this way. STL engine. One thing I'd really like to do is not have all these globals in STL engine at some point. Make them, you know, maybe do the same thing. Have Pimple here and just put these in a class. Just have a way to like manage it more cleanly. Say STL audio driver. Okay, so here's where we initialize rendering. I guess here would be a good place to initialize the audio driver. What was I using get buffer usage ratio for? Oh, it was for debug drawing. Yeah, that was useful too. I'm probably going to do something similar using, this time using ImGUI. Have like a bar that shows how full the sample buffer is, to get a feel for if we're filling it fast enough or not. Yeah, I realize I don't do a very clean shutdown in a lot of cases here. Like GL render should be shut down here. Even though it doesn't do anything. I'm calling this guy. See, I should call this. So it's basically create context, do this, GL render audio. So shut down audio, shut out GL render, then shut down ImGUI's thing. Okay. Should really be in the reverse order. And the client should be shut down like that. Okay, well let's just see if this launches. We might hear a little pop or something, I don't remember. I think there was something with the audio when we initialize it. Or not, because it's clean, I suppose. should be hitting that callback. Let's just see. And we're not. So why? I guess because we're not adding samples. Could it be? No, that's unrelated. Called initialize. I'll try and debug just to see what's going on. Oh, and debug. This is not big enough. Okay, so you're not seeing this, but I got an assert front called on an empty vector. So that's my circular buffer, and that is going to be max size 0. Clear. Ah, interesting. I guess I never tested this. This is something I added on this. No, this was here, right? Oh no, I did add this constructor. Huh. Okay, so I guess I had never really tested this properly with a max size of 0. Interesting. You're not allowed to call front on an empty buffer. I guess I can't call back either. What should this do? Basically I have two choices. Either I support a 0 size circular buffer, which I suppose would be the right thing to do. And then what, do I resize it soon after? Oh yeah, right here. more of a hack than anything else, but it's okay. Okay, so now we get here. Buffer size 4410. I see, I wrote this. We wait until the buffer is 50% full to start playing. Okay. And what about my callback? Oh wait, I think I know what's happening. It's sad that SDL open audio device didn't give me 0 though. So I think what's happening is that I need to pass in a flag to SDL to say that we want audio. But like, just if we run this again, we should. I guess it doesn't consider it an error, it just will be silent. There you go, audio device ID is 2. But I guess it just, it's kind of like a null object. If you don't initialize, it just doesn't crash or doesn't cause any problems, which I guess makes sense. You just have to be conscientious of this and actually SDL init. So we want init video and we want init audio, that's what we want. That ought to do it. Or not. Now I didn't even hit my callback, my thing at all. Yeah, I don't understand. Why am I not getting my call back? Oh, I think I know why. No. Yeah? Maybe? No, I don't know. No, I really should be getting it. got an audio device ID of 2. Anything interesting in the actual versus the desired? Okay, so we got the same frequency, same format's not quite the same. $32,784 and we got $33,056. So we didn't get our signed 16. $81.20. 32-bit floating point samples. How's this different? So we're getting 32-bit floating point. Not. It's possible that we were getting this also, and maybe that's why I wasn't storing the actual output. We ask for the one that's most supported, and we end up with something else, that whatever the driver wants. So that's fine. It wants 32-bit floating point. That's okay. What else? I asked for 1 channel. We got 2. Okay, that's all right. Silence 0, samples 400, padding. I've got a size 8192. I've got a callback here that's been mapped. My user data is a pointer to this. That looks the same. Oh, wait a minute. Oh, okay. Yeah, okay, so it's because I'm not adding samples. And so when I'm not adding samples, I have this code here that checks for when we pass our 50% ratio here, and I pause. So, okay, basically I say unpause when buffer is half full, pause if almost depleted to give buffer a chance to fill up again. So this was my code to kind of manage. Yeah, to manage that based on buffer fill, how full the buffer is. Basically, if we're under 10% full, we are paused, and as soon as we cross 50%, then I unpause so that the callback can start consuming. Okay, yeah, so we're not gonna get this callback at all. We're gonna do that. We're gonna do some work on that. First, I think we have enough to check in what we have. Let me just make sure that closing the emulator now exercises that code we just wrote at the end of run. Make sure that it works fine. Shut down, shut down, shut down, shut down, destroy, destroy, quit. And we're good. Do this separately because it's not really related to audio. shut down GL render and in GUI. And clearing with okay, whatever. And there was one thing I wanted to check also. What was the deal with why did I do this again? I think this is old. You don't need to do this anymore. Okay. Add SDL audio driver, or I'll say something like from NESEMU with changes. With some changes and init shutdown. Enable audio. All right, so what I was thinking now was about this add samples thing and whether or not it's going to make sense to do it the way I did it before. I think what I'd like to do is maybe be able to add as many samples as I want and provide the delta time, because that's pretty much what we're going to do. Yeah, that's kind of like the advantage. We can keep this fully time-based.
It's the freshest you've ever seen him. Roll the bass, rock the party through the evening. It's past the disco, beyond any club. You gotta be legendary funky to be allowed to eat and show up. But if you make it in here, you're in for one hell of a night. Cause the party won't stop even if you want it to. The beat takes a hold of you. The funk is so hard it's taking over you. Old Jack is now controlling you. But then
how does that work? Previously I knew that I had a fixed frame rate, so I could just count the number of times we added samples for every frame and then just divide. But now if it's variable frame time, I suppose I need to use the time as a weight. We basically want like a weighted average of all of them. So I sum the elapsed time and I multiply each one by the delta time and keep a running total of that. Yeah, I suppose.
Make your way to the dance floor. Don't waste no time. Don't even waste no time. Make your way to the dance floor.
Like something like.
Don't even waste no time. Never look so vibrant, too like a tyrant, but colored in violent oranges, yellows, and reds.
I gotta call it frame time, right?
Big tunes from the speaker heads.
Yeah, and actually it's a double everywhere else.
Wearing son of a soul eater. No ghost stories around the campfire. Just a crowd yelling for him to turn the volume up higher. Never seen a scene like this before. Everybody all on the dance floor. Break dancing going on hardcore. Get your hands up, throw him an encore. The piper, rule is subjects. Move even if you don't know the dance steps. Get funky by all accounts. Now make your way to the dance floor and bounce. Bounce, bounce, bounce. Let me see ya. Bounce, bounce, bounce. Everybody just bounce, bounce, bounce. I wanna see ya. Bounce, bounce. Everybody just bounce tonight, man. Come on.
Okay. I guess we'll call those subsamples, maybe. Or maybe not, I don't have to expose that, but internally we can consider that a subsample. And what we want to do, I think here, what do we want to do? We need a running total. Actually, I don't need, yeah, I don't need a vector at all. I just need a float. So something, let's like something like this. Or maybe total samples, total time. That's really what it is. Now, the part that I'm missing here is to know when to actually add a proper discrete sample, which is what these are. Hey, Will25, how's it going, man? Yeah, I'm kind of surprised that I got away with not using the actual value returned from the sound card, because doesn't that mean that if the frequency is different from the sound card and I'm not using that number, it's not going to work? What the hell was I doing? It's not this. It was APU. This is what I was looking for. Okay, so we know how many samples per second we want. So we just need the inverse. Seconds per sample. Okay, so we want seconds per sample to be computed here. Oh, hey Neopiece, thanks for following. Appreciate that. So seconds per sample is going to just basically be this over the sample rate. Again, the sample rate is using the value in the audio spec, which we are not correctly updating. So I'm going to just make a little note here, like this really should be actual. Why aren't we using actual? We'll mess with that once we got something working. We'll see if it makes a difference. We saw that we got a different value here already, so. Although, did we get a different frequency value? You know what? I don't know anymore. Let me take a look. Does this actually compile right now? Not yet. Conversion. Double to float. This is gonna be a pain in the ass. Oh, and total samples. This is supposed to be total time. Guess I'll make this double. Still wondering whether I should have ever gone for using doubles everywhere. I might at some point just go through all my code and change those doubles for frame times to floats. I don't even know why I did that. Okay, see, I have to deal with stuff like this. But you know what? In this case, actually it might make sense for the total samples to be a double. It's just for precision. I don't know how many samples I'm gonna get, but I might get a lot. Sorry, I saw that. Will25, do you know how to program with Java? I mean, no and yes. I did some Java a long time ago. When I was in university, I actually TA'd a class with Backface Cullah, who's actually here, actually, as it happens. We TA'd a class for operating systems, and Java was being used, so I had to like learn Java quickly to help TA the class. I never used it professionally, but you know, I've looked at Java code here and there and modified some, but I'm definitely not a Java like expert, or you know, I haven't spent much time with it. Why do you ask? Okay, so we are getting the same frequency in both, so that's probably why it didn't matter, since I really cared mostly about the frequency. Okay, so that should be okay. You know what? There's no need to really to cache this, is there? All right, so we do this. If our subsample's total time is greater than seconds per sample, or maybe what we do is we just keep subtracting while it's, what do we want to do here? Remember I was talking about whether I should take H Pre-Cal or AP Computer Science? I'm taking both next year, but the Computer Science class focuses on Java, and I've been practicing C++. You think it will confuse me? Well, that's a great question. So what I'm going to say is, so I don't know Java, but I definitely know C#. And there's really a lot of similarities between Java and C#. So I can speak about Java in that way. You know, both, in fact, C# is a language that's actually technically born from Java. There's an interesting history about Sun suing Microsoft and for modifying, like, for having their own custom version of Java, and eventually they settled and decided to stop supporting Java and made their own language, which is C#. But anyway, I digress. So to answer your question, I personally think that if you learn C++, you can learn pretty much any other language, because most of these languages are actually written in C++, including Java and C#. Or put another way, C++ is hard, right? It deals with memory management. Like you have to deal with memory management yourself. You have to understand the machine a lot more. And I think that languages like Java and C#, although they have their own complexities for sure, they are garbage collected languages. And you know, the whole idea of these languages is that they're easier to use. They're more easy to like, you don't have to worry so much about memory and stuff like that. And personally, because I learned C++ first, when I learned C#, I learned it in terms of C++, which helped me. And when I learned about garbage collection and how it worked, I was able to reason about it. I was able to reason about it in terms of how it must be implemented in C++. You know, I could imagine that, you know, like I could imagine how a garbage collector must work. You know, I never wrote one, but I would read about it and go, oh, okay, I guess, you know, then I would implement it this way in C++, you know? So yeah, I think it's not a bad idea to learn C++ first. All right, Backface, I'll talk to you later. So yeah, I don't think it's a bad idea to learn C++ first. I think once you have a good grasp of how the language works, a lot of stuff is similar between C++ and Java. You know, the whole concept of classes and object-oriented, like the way it's implemented with virtual functions, inheritance. You know, in C++ does more, like you can have real multiple inheritance in C++, and in Java you can't. You have single inheritance, and so you can only inherit like one class. Otherwise, you can inherit or implement multiple interfaces. So that's not really the same thing as in C++. So in a way, it's simpler, right? You don't delete any memory in Java. That's where the garbage collector comes in. So it's a bit simpler. So to me, it's like kind of like if you learn the more complex one and understand it, then when you move to languages that are, in my mind, higher level and simpler, it should be easier to learn. So that's my opinion. It's more of like a bottom-up approach, I suppose. I know some people that kind of approach it the other way, kind of more of a top-down, you know, you learn the easier languages and then you make your way down to the harder languages, because then the whatever makes this language harder than the previous one, that's the extra level of complexity that you have to learn, you know, and then maybe that's easier because you've got the basics down. So that's another viewpoint, you know. So that's my 2 cents. Hey, no problem, Will. I'm happy to answer these questions. So maybe what I'll do is say, while this minus seconds per sample is still greater than 0, do that, and then add an actual discrete sample. And now the sample that I want, oh yeah, and that's the thing, right? Yeah, I don't even know how to do this. I guess I need to use like a ratio of the samples. Okay, I'm gonna do this kind of dumb for now, but I need to do this correctly. For now, I'm just gonna say, if we pass the total time, we're just gonna consume the whole thing. We're just gonna assume one discrete sample. And this is not really right, because if we have like one large frame, we should be adding multiple samples. But yeah, well, I'll have to figure that out. I know what we'll do is we'll say take the total samples here, which is actually a weighted sum. I'm going to call this add discrete sample. I think it's going to make more sense to me. Why doesn't it like it? Oh, because I'm not done. And then we'll just, for now, we'll just clear these two. This is not the right way to do it. Need to add I should do like course. Or maybe what we'll do is we'll do it the other way around. I will call this add subsample or something like that. And we'll call this add sample. Okay, I think that makes me slightly happier. All right. So with this, we should be able to go to the STL engine. And for now, just add samples of a value of like, we'll just let's try adding a value of 0 and just seeing if we get our callback. And then after that, we could try to add like, we know, some random values and see if we get some bad audio, like some noise. And that'll be a good start. Yeah, see how we pass in the render context here? After passing in the render context, we're going to want to do, we're going to want to pass in our audio context in here as well and pass that down and consume the samples from there. the sample, actually, I should say, for the current frame. G audio driver dot add subsample, and we'll say for now 0, and we'll say frame time. It is 11 o'clock, so I'm actually going to be ending my stream fairly soon. What does it like? Is this why I was getting this? Probably. Function definition for add subsamples not found. What's the deal here? Oh right, yeah, I gotta add a forwarding function. Okay, that's what this is about. Yeah, fair enough. Okay, let's have Visual Studio do it for us. Impl add subsample frame time. Okay. No, nothing. Let's see what's happening here. Yeah, I think we're never getting to the point where our buffer is full enough. And that's probably because we're running in debug. I'll have to try this in release. And there's more too. I realize now that if our frame time is too large, this is exactly what the problem is. We're not adding enough samples. Yeah, this comes back to the problem of not adding enough samples. Maybe what we want to do is just add as many samples and just use the same value over and over. Maybe that's okay. But before I do that, let me just try and release with debug info, because I think then we should definitely be fast enough to fill this buffer. This is the kind of stuff you have to deal with when you're doing audio programming. And I'm out of water. Nope. So we actually did unpause the auto driver, but I think it must have gone back to pause. I guess this code isn't working as expected. And I think it makes sense, because what I'm doing is I'm just doing a greater than or equal check, but that's completely wrong. So we're gonna have to do this correctly. is large. Add the same sample multiple times. That's right. To be honest, I'm too tired to figure out if this is right, so sleeping on this will probably help me figure out what's the right approach here. Nice if we can see if our callback gets entered. And we do get entered here. Okay, so now we are getting our callback. So technically there's audio here. I see an entry for it in my audio mixer in Windows, so that's a good sign. So let's say we were to just try to add some noise just to see if we actually get something. I don't know how horrible this might sound, but let's find out. Like, what if we added always the same value? I don't even remember the range here. Assigned. I'm gonna stop my music for a sec. Okay, well, we're hearing something, but definitely it's not constant, and that's probably because we're cutting in and cutting out. So that's related to yeah. All right, we're gonna stop here. I'm gonna think a little bit more about how to do this correctly. And yeah, and we shall resume in a couple of nights. So it should be on Thursday. Same time, same place. So guys, thank you for watching, and I hope to see you next time.